Welcome back. This is part 2 of the Outlander drivability bug. So I did part 1, we did a road test, went through some things on the drivability bug that is installed on the 2014 Outlander Sport, and I put it to my students, what should we do next? And an overwhelming amount of you wanted to test the O2 sensor and the mass airflow. So I've got some tools here. We're going to go through, we'll do the O2 sensor first, use some propane to force it rich, see if it can respond, see what its activity looks like with that. We'll create a lean condition just to see what both sides of the spectrum look like. Let's get started. So to test this O2 sensor, we're going to do something that's not necessarily an everyday shop practice, but we're going to use some propane as an additional fuel source to see, can we get that O2 sensor to move? It's really stuck quite low, only reading about 40 millivolts right now and not switching at all. And so we know that that's not a good sign. We want to see, does that sensor have the ability to show us a rich reading? So I'm going to take my hose on my propane, give it just a little bit slowly. We should see an idle change. See there, we had an idle elevate. And we can see on the scan tool, that sensor had the ability to very quickly see an addition of fuel. So you can see each time that I add the propane, we get a lot of O2 sensor activity. The very first time I added that propane, we saw a surge in the idle. The idle actually climbed. And one of the things that can tell us is that there is a lean condition. And so that speaks pretty well to what the O2 sensor sees. The other test that we could do that would be a way to look at the range of the O2 is to simulate a vacuum leak. But because our O2 sensor is already bottomed out more or less at 40 millivolts, that test probably is not going to tell us a whole lot. So based on that single test, we see that our O2 sensor can read a rich condition. It responds very quickly to reading that. And so I'm going to take that as information at this point that I think my O2 sensor can do what we need it to do. So the second test that was very popular with students that under my suggestions was to check the mass airflow. So we'll go look at the airflow meter now, and we'll compare that to some specs, and we'll see what we think. Here we've got both PIDs pulled up for the airflow sensor on this particular car. We get a millivolt reading, somewhere in the 900s, a little bit of fluctuation, and with grams per second, just under 3, we're at 2.9, 2.8 and some change, again with just a little bit of fluctuation. So with those numbers in mind, we're going to go to all data. We're going to see what kind of specs we get. All right, so here we've got our specs. We get a listing for both our millivolts and our grams per second. And if we compare the two, based on the millivolt reading, we're a little bit low. On the grams per second, there's quite a wide range. So even at idle, I can go anywhere between 1.3 and 5.3 according to this chart. So we'll go back, we'll rev the car. The other notation here is I should be somewhere between 5 and 13 as I rev the engine to 2,500 RPM. So we'll switch back to the scan tool, rev it to 25, and we'll see what kind of change we get. Right there is 2,500, and then we'll give it a couple snap throttles and see the response on that as well. All right, so we did our test and basically got some numbers that fit the parameters that Mitsubishi put out for testing that mass airflow. The challenge that we've got is we did a static test in the bay at idle, free revving, no load. And we're comparing that to a driver and customer concern under load and wide open throttle. And so much like other areas of testing with vehicles, we're inconclusive at this point because we're not comparing apples to apples. So we've got to find a way to do a more dynamic test. And so here we're looking at the data from the road test that we did. And so we had as much as about 72 grams per second as we went through about to 5,000 RPM with wide open throttle. So one of the things that we can do, if I don't understand what these numbers are, I can take them and plug them into a VE calculator. So volumetric efficiency is a way to equate and measure and calculate the loads and amount of airflow that go through an engine. And calculators like this one from Automotive Training Group do a great job of taking that data and also putting some other measurements like grams per second, IAT, these other variables in place to help you understand, is this thing where it should be in terms of volumetric efficiency? Engines don't run at 100% unless we're running forced induction. So with a naturally aspirated car, we do expect to be at least at about 90%. So here's a screenshot. I took the data that was relevant for our Mitsubishi, having a 2-liter engine. We revved to about 5,000 RPM. I saw 72 grams per second. IAT was about 100. We plug all that in, and that shows us we've got a theoretical load in VE of about 75%. And so if we begin to dig into what does that tell us, really that it is lower than it should be based on the data we put into that calculator. And so ATG also does a great job with their instructions that they give you this pinpoint test. And so if you follow through this, the VE test failed, we have a positive fuel trim. And so that quickly pushes us out to look at the mass airflow, look at the intake duct, basically look for, is there false air readings or misreadings that are occurring? And that goes perfectly with what's going on with this car. Let's take a look. So we'll go ahead and pull the airflow meter so we can do a visual inspection of it. And so this is what I did to create the bug. So this is the opening for, the hot wire elements. I had a piece of tape covering that just to slow down what kind of air could get through there. And so because it had some opening, it worked fine at idle. And a lot of our testing showed that specifications at idle were okay. But a lot like electrical testing, it's under load, when it's really put into a dynamic range, is where you might see a problem. So that's where the road test was really important with this. Comparing those numbers for volumetric efficiency is where we really win and really gain some understanding about whether or not this sensor is doing its job.